Hello everyone, welcome to Data Dive. Today I'll be talking about time series forecasting methods. This will be part one in a two-part series. In this first video, I'll cover forecasting methods characteristics and the characteristics of time series themselves, both of which are important for setting the foundation before getting into part two, which will focus on the various forecasting methods and a brief discussion on choosing between the models. Okay, let's talk about model characteristics. Models for forecasting can either be univariate or multivariate. Often, we're just interested in a single variable. For instance, we might want to predict the weather, or maybe the stock price. Sometimes one variable is all we need, but predictions can be improved with other data. That's where multivariate models come into play. These models incorporate external data to generate forecasts. An interesting example might be Brewster's, which is an ice cream chain. Now, I don't know if they still offer this promotion, but I know at one point they offered a free scoop of ice cream along with a purchase on a rainy day. So knowing this, perhaps we could try to forecast sales based on the weather and some other factors such as holidays or planned promotions. The next model characteristic deals with the forecasting approach. Most models are designed to forecast one step into the future. However, these models can actually be converted into a multi-step forecast through a concept called windowing. The graphic on the right, which is from Esri, provides a good depiction of that process. The downside is that because you're using predicted data to generate more predictions, errors can quickly accumulate the further out you forecast. Meanwhile, models capable of multi-step forecasting out of the box can do this without windowing. So it can basically take in a set of inputs and then spit out multiple predictions all at once. But this generally requires a more complex model or set of models. Up until now, we've focused on forecasting point estimates. However, time series forecasting models can be adapted to provide probabilistic forecasts, where there's a prediction interval. The chart below provides a good example of how those prediction intervals are being used in these energy consumption forecasts. And the nice thing about having probabilities and prediction intervals is that they can actually be used as inputs for scenario analysis or optimization models. Now let's turn our attention to some of the key characteristics of time series, which will be useful for understanding many of the forecasting methods in part two. So what makes up a time series? The idea that we can decompose a time series is a fundamental building block of many forecasting models. Basically, a time series can be comprised of three components: the trend, seasonality, and the error, which is also called the residual. Together, these three aspects can be used to generate forecasts. It's also worth noting the concept of stationarity, since it's a requirement for certain forecasting models to work. And basically, a stationary time series is one that yields a constant forecast. And basically, the statistical properties of that time series doesn't change over time. Autocorrelation is also another key characteristic. And this measures the degree to which the time series is correlated with its past values. So in other words, we're just trying to figure out how similar are the data points from today to those in the past. And you will likely run into these autocorrelation charts, which help you assess those relationships. Two other facets to consider include sparsity and variability of the time series. This is something that shows up especially in demand forecasting or supply chain analytics. If you're trying to predict the demand for a product that exhibits a sparse or intermittent time series, you probably will want to choose a specific set of models to do that. And this is much different than forecasting aggregate sales across numerous products, where your time series is more likely to look smooth. As such, there's generally a trade-off between the quality of the forecast and the ability to discern specific details or patterns. Okay, that's it for part one. Thanks for watching, and I'll see you in part two for an overview of the various forecasting methods.